welcome to Edon. Our today's topic is a continuation of complex number. This is a fifth video of a complex number series. So in today's topic, what we're gonna discuss is singular points. So singular point is a point at which fz is failed to be analytic. Analytic, we know about the analytic function. What are analytic function? Which obeys three conditions. That is, first what is the first condition? First condition is a continuous, that it must be a continuous. It must be a second condition, it should have a unique derivative. And third condition, CR equations. What are CR equations which need to be followed? That is, du by dx is equals to dv by dy, and dv by dx is equals to minus du by dy. U and v, part of a function, u is real part and v is imaginary part. Fz, how it is represent? Fz is equals to u plus iota v. So let us see the types of singularities. So there are 6 types of singularities. The first singularity is poles. Second is singularity at infinity. Third, you can say a branch point, removable singularity, isolated singularity, and essential singularities. In this video, we will go in depth and read about all these singularities. So first singularity which we're going to discuss is isolated singularity. What is a singularity? A point at which f dash is failed to exist analytically. So first is isolated singularity. As the name suggests, isolated means no other singularity, means it does not have anyone in its neighborhood. Any singularity, by anyone I mean any singularity. So if z is equal to z naught is isolated singularity, there is no other singular point than z naught. If it is not isolated, means singular points, then it is known as ordinary point, or can say that ordinary singularity. Now let us see the poles. What are poles? So in poles, let any function in the form of limit z approaches to 0, function z minus z naught raised to power n fz a is equal to any number a. So if we put z is equal to 0, z naught, so this is a pole, and this n is equal to the order of a pole. If n is equal to 1 at z is equal to z naught, then it is a simple pole and it is not as order of pole. This theoretical seems to be confusing, but let us see with the example. It was more clear than with example. So in this example, first example. Suppose this function is given to us. For a pole, always remember that pole exists in denominator. So for pole, let us substitute this and this to 0 one by one. Substituting this to 0, we obtain minus 4, that is plus minus 2 iota. So plus minus 2 iota which we got is, what is it? These are poles. What is the order of the pole? 1. So this is called simple pole. Got it? What is a simple pole? Now let us put this is equal to 0. Now substituting z plus 3 iota is equals to 0, we get z is equal to plus minus 3 iota. So plus minus 3 iota is known as poles of order 4. Similarly, looking at second example, let us put z minus 1 is equal to 0. So z is equal to 1. What is it? Pole order 2. Sorry, this is a written mistake. It should be order 1, that 2 plus 2 iota. So what we are discussing is it. Substituting this is equal to 0, then pole of order 2. Similarly, this substituting it is equal to 0, then z is equal to 2 is equal to pole of order 3. So by poles we are getting 2-3 points. First point, pole is always in denominator. Substitute the parts of a denominator is equal to 0, we will obtain a pole. And if the order is 1, then it is known as simple pole. Moving to the next, this is the example which we already discussed. Now branch point. What is a branch point? A branch point usually occurs in multiple valued function in which different value of z exist. If different value of z exists, so already a function is not an analytic function in the neighborhood of branch point. Now this is something, a theoretical. You cannot better understand without example. So without wasting a time, let us see example to understand a branch point. So let fz is equal to z minus 3 and raised to power half. So if we put z minus 3 is equal to 0, then z is equal to 3 is a branch point. Now you will say that why it is not equal to pole? Because whenever pole exists, at that time the function limit does not define. But here the function limit is defined because it becomes 0. Even if z approaches to 0, the function becomes 0. So the function limit here is defined. So whenever we have anything in numerator and we have to find a branch point, we put that equal to 0 and the function limit always exists. Not as undefined in pole. Pole always occur in denominator. So the limit does not exist, but here the limit exists. So next we are gonna discuss is removable singularity. As the word suggests, removable. A singularity if it can be removed from the function. How it is possible? It is possible that if this limit exists at that point, then it is known as removable singularity. Now let us see this also with example to understand better. So let fz is equal to sin z upon z. We know the limit z approaches to 0, sin z by z is equal to 1. Therefore, z is equal to 0 is removable singularity. Essential singularity. So essential, if we are gonna discuss about essential singularity, as the name suggests, this singularity cannot be removed or neither it is a pole. That neither it makes a limit undefined or neither it will removable. Let us discuss also it with example. So let us see the example of essential singularity to understand it better. So let us take this function e1 by z minus 2. So if we put z is equal to 2, then it makes the function undefined. But there is no way to remove it. So it is not a removable singularity. Neither it is totally in denominator, so neither it is pole. So this is essential singularity. Moving on to last type of singularity, that is singularity at infinity. As the name suggests, a singularity which exists at infinity point. When z is equal to infinity and there is any singularity, that singularity is called a singularity at infinity. Let us see this also by example. Let a function of fz as f1 by w. So at w is equal to 0, this function turns to be infinity. Therefore, this w is equal to 0 is known as singularity at infinity. I hope you all get the singularities and understand it better. You revise 2-3 times or watch the video, then you will understand and you will memorize the things. We will later do on the questions on it also. It is just an introductory video, and it only is about giving a brief introduction. We will explore this topic later. So thank you for watching. Thank you so much. Do mention your comments on video that how do you like a video and what part is clearer to you. Thank you.